This is the Earley AI Podcast, hosted by Seth Earley. Join us as we delve deep into the passions, expertise, and experiences of thought leaders and practitioners to talk about what's possible with artificial intelligence. The Earley AI Podcast is sponsored by Earley Information Science, your digital transformation journey with design and deployment of innovative technology solutions, as well as Vector. Now enjoy the show.
Welcome to the Earley AI Podcast. My name is Seth Earley. I'm your host, and each episode explores how artificial intelligence is shaping how organizations manage information, make decisions, turn knowledge into real business outcomes. Today, we're talking about what it takes to scale AI in the physical world, not just in labs or demos, but in production systems at the edge. Robots, cars, medical devices, and other intelligent infrastructure where performance, efficiency, and reliability are really critical. And as AI expands beyond centralized computing, questions around cost, power consumption, latency, operational readiness, those are all becoming very important. So joining me today is Krishna Rangasayee, founder and CEO of SiMa.ai. That's SIMA. Krishna works at the intersection of AI software, specialized hardware, systems architecture, and his focus is on delivering efficient high-performance AI at the edge, enabling intelligent systems to operate closer to where the data is generated and where decisions are made. Krishna, welcome to the show.
Thank you, Seth. Such a pleasure. Thanks for the great intro, too. Wow. I need to get this for later use.
I know. It's always when people introduce you, you're like, oh, wow, did I write that? Anyway, so let's talk about, I'd like to start off with when people think about AI, they're thinking about chatbots, they're thinking about cloud models. What do you mean when you talk about, when we talk about AI in the physical world? How is that fundamentally different, and what does it really mean?
No, and I think, AI has gone through its evolution where I think the footprint was mostly consumer along the lines of ChatGPT or LLM agents. And in the cloud construct, we have derived benefits of AI for 10 years, 15 years. And what I think we're going to, and that's taken, if you will, an evolution for the last 10, 15 years. AI in the cloud, AI in the consumer persona. I'm totally convinced that where AI will really bring value to human beings is when it touches our lives every day. So for cars, for medical devices, for home appliances, things we live and breathe and touch every day, as and when AI starts coming into our lifestyle, is when I think we're going to truly see the benefit of AI. And so it's not that the cloud is going to go away. There is a reason and there's a value that the cloud's still going to retain. But increasingly, you're going to find a balance between the physical world we live in, benefiting from it, and coexist with cloud infrastructure.
So you said that the industry is moving from rules-based computing to machine learning, and what has really changed in the last couple of years? We know that this has been emergent. We know it's been around for a long time. We know that the AI in lots of incarnations. But what do you consider as the real inflection point? Obviously, large language models are critically important. But what else would you say is really causing this?
So if you really take a step back, neural networks have been around forever. So this is not a new concept. What's really, I think, been interesting is our ability to be able to deploy neural networks in a commercially scalable way is the big difference that chips are enabling today. So we have seen the benefit of what was CNN, convolutional neural networks. We saw the evolution of transformer-based architectures. And broadly, though LLMs are capturing the mind of everybody today, reasoning-based architectures was for the first time in humanity ever being able to be commercially deployed in a form factor that's digestible in cost and in power. And we are seeing this in the cloud along the lines of chat agents or chat bots, but you're going to see reasoning-based architectures and the compute paradigm shift from rule-based to analytical to now context and memory aware, like human beings think. This is for the first time in the history of humanity.
Right.
We're all looking at this big tipping point. I'm sure historians are going to write about this tipping point for a long, long time to come. So this is a renaissance age for computing. So we're in an amazing time.
Yeah, it really is. And every day, every time I use a large language model, I'm astounded, and you start taking that for granted. You start, then you start getting angry when it misses something, when it, you're giving these complex documents and you're asking all these questions. It's like, you missed this point over here. What's wrong with you? Oh, I'm so sorry. It'll apologize. And yes, you made a good point. I'll go back and rethink this. And it's like, you're really interacting with something that is kind of mind-boggling.
Absolutely. No, I would say, I mean, I think LLMs are the reasoning architecture flavor of the year. I promise you that every year there's going to be an evolution. We're going to get better and better at it, where models will get more accurate, more personalized, and more context aware, and be able to really be nimble and quick. And we are seeing so many implementations of it, even in the physical AI world.
So let's talk. You mentioned we talked a little bit about inference, and a lot of times people blur training and inference, right? They think about just AI and training these models, but they're very different. What is important, especially with physical AI systems, in the terms of the difference between training and inference?
Sure. Training is a very different universe than inference. And so I'll take a step back. So training is where you have a set of data. You're training a model to really recognize the data and really learn along with the data set. So when you're given a new data point, you know what to recognize and what probability to place that at, right? So in the early days of AI, training from a revenue and from a market focus has taken on the biggest footprint. So inference is relatively a smaller market compared to training. But once you train these models and once you start deploying them in the cloud, and increasingly now in the physical AI world, it's going to be more and more an inference world. And you're going to see that the inference market is going to be 10x, maybe even an order of 100x the size of the training market going forward, because you don't need training everywhere. Once you have really trained a model, it's now scale up deployment. And it's going to be more and more an inference world, particularly in the physical AI world. And SiMa as a company, if you will, we are an inference company.
And inference is really giving the AI model the problems to solve. It's actually doing the work once you have the training completed. Correct. And that requires really a different way of thinking about power and different way of thinking about architecture and so on. When you think about that, what's particularly important in physical AI and AI at the edge, and what makes it a different problem when it lives in a robot or car or medical device?
Absolutely. So let's start with the basic of problems. While cloud really doesn't care for power, they should. They're really more about they have to. But at this point, people are having a fear of missing out and a mad rush to enable capability without thinking through the power implications.
Right.
At the physical AI world, you actually have no option at all but to really think through power. AI world tend to be 5 watts or 10 watts, and that's the limit of what you really have, right? So power and thermal are huge limiters. So you cannot take a GPU that you use for training or a GPU that you're using in the cloud and assume the same architecture will hold that same value at the edge. And at the edge, power and thermal are unforgiving. You almost go the other way, saying, hey, I have 5 watts, I have 10 watts. What capability can I fit into 5, 10 watts? So that's problem number one. Problem number two is the sheer variability and the sheer scale of it. In the cloud, hyperscalers, it's 7 customers. The physical AI world is thousands, tens of thousands of customers. So the scalability of the problem in being able to be cost efficient and also really software flexibility is really at the very key, right? So the needs of the edge or the physical AI world are very different. The third large variable is in the physical AI world, you and I are living with robots, you and I are living with cars, safety, security, privacy, and if you will, human machine interface and the real world has huge implications architecturally that you don't need to worry about in the cloud. If your chat GPT or your chat LLM agent made a mistake, nobody died.
Right.
That's not the case in a car, not a case in a robot. So you're living through safety, privacy, security constraints that are radically different than in the cloud. So our outlook is that I think there will be a new class of architectures that will have to be built for the needs of scaling for the physical AI world that are quite divergent, if not quite different than what's being used. And that's our this is behind why we started our company too.
Yeah. And so what are the misconceptions? What do executives not understand when they look at deploying AI into real world systems? What are they not understanding? What are they missing? What are the misconceptions?
So I would say
You're touching on them here, but I just wanted to kind of
with all new technologies introduced into traditional industries, the learning curve of what it takes to scale something in production has a longer timeline than everybody expects. One popular misconception people have is they think AI is magic and that you just show up and, as somebody said, it's like a Betty Crocker moment. You just add water and it works. Far be it from the truth. AI is really a large predicator on the quality of the data that you train this on and the quality of the data that you have. What's the other adage is garbage in, garbage out.
Sure.
So people overlook the fact that a model is only as good as how well it's trained. A model is only as good as how well it's deployed. So that's one popular misconception. The second one is people don't understand the life cycle of AI in that it's not about showing a proof point and getting it done. In rule-based compute, you get the problem right once, you can then scale that as long as you want. And the rule-based construct doesn't change. In AI, there's every day a revisit to where's my model, what's my drift, what's my false positive, what's my false negative. Am I learning from the mistakes that I'm looking to? And there's an ML operations infrastructure, ML ops infrastructure that helps lifecycle maintenance. And so AI is a perennial, everyday learning, breathing entity. Nurturing that infrastructure to scale is radically different than what people are used to. So these are new paradigms. I have no doubts that we'll look back in this phase and laugh at some point. I joked in some of the forum that when we discovered fire, we went through the same hazing ritual too. Exuberance will fade. Pragmatism will settle in.
Fire stuff is really useful, but wow, it's dangerous.
So it's no different, but AI is overly hyped to be very simple, particularly the physical world. It's a lot more complicated.
Yeah. And what do people underestimate? I mean, you're alluding to some of these things. What do they really miss out? What specifically do they not understand? What do they underestimate when they're trying to build this out in the physical world?
No, I think they need to think through the life cycle consequences. So that's number one. Number two, I mean, less in the physical AI world, but we see a lot of companies getting into AI for the sake of AI.
Sure.
And what really matters at the end of the day is two things. What is my use case? What's the tangible delta I'm going to bring with an AI-based infrastructure? And third, no wonder, I mean, no doubts the capitalistic element of will this make revenue? And will it make me profit? And so these usual suspect things cannot be just saved by a magic wand of AI. I mean, AI is a tool, but it doesn't take away for use cases, doesn't take away for deliberate lifecycle maintenance and management outlooks, nor does it take away for revenue and profit. And take the consumer world today. I promise you, 80-90% of the companies that are building wrappers around LLM agents may not be around in a long time because end of the day, it's a capitalistic world.
Sure.
Revenue and profit matter.
Right. You talk a little bit about lifecycle management. What are the stages that you need to think about when you're looking at AI and lifecycle management?
Sure. So I think it's in some ways no different than what we've traditionally done, but there's devils in the detail of the amount of variability and the amount of AI that you need to face. So I would say no doubts everybody starts up with a POC or a proof of concept phase and saying, hey, I've done this all my life with this outlook, or it's a new problem solving. Let me prove out the capability of a proof of concept. What will I get out of it? What cost, what power, what accuracy, what capabilities will I get out of it? So that's one phase where it's a very different set of dynamics and needs, even a very different set of an organization that does that. Then you have pilot phase where you say, okay, I'm going to deploy it over 10 systems. And I'm going to now get an aggregate outlook of if I do it over 10 systems or a projected 100,000 systems one day, how would it look like and how would I deploy? The third one is I'm now in volume production and I've deployed it. How do I maintain it? How do I upgrade my models? How do I get better data? How do I make my system more accurate? How do I make it more feature capable or feature rich? And then the last one is maybe this has reached its final stage of value and I need a totally different foundation for it. How do you phase out an existing production program and how do you phase in? What I'm describing to you is a standard engineering deployment phase that we have lived with for 100 years or maybe even more than that. But the AI-centric implications of it brings an entirely different outlook, an entirely different set of organizational capability that not every company in the world is sitting with a commensurate, hey, I'm ready to go. So we're all practicing and preaching and learning simultaneously as we
True. Yeah.
And the world's moving so fast. The
Right.
pace of innovation is so radically different. And most of the physical AI customers have been around for 50, 100 years. And they built their strength and competencies in different areas. And AI is a new muscle that they have to gain. And so expectedly, it's going to take time. But none of us are patient, and we all want results tomorrow morning. So human beings, as long as we remain who we are, will struggle through these every day. Yeah. But if history is a proof point, we'll all get across the finish line. We'll be excited for the new world that we're getting into.
And where are you seeing the greatest impact? And give us some examples of where, the efficient edge inference has changed what systems can do.
Sure.
So give kind of some examples of what that look like and what's possible.
Absolutely. And so I would say I'll park it into things that we've already seen already, and there are things that I think we're going to see. Simple area where things have changed a lot is drones. So these used to be pretty mostly consumerish toy elements.
Right.
And you're going to see that drones are going to be a huge component of our life in mobility. In 2-3 years, very rarely is somebody going to drive to your place to hand off a DoorDash or a food delivery or a grocery delivery. Majority of it is going to be drone based. And so this is one area where power matters a lot. There's a lot of mobility and mapping and targeting and safety that needs to come in. But this is something that's already at scale today, and you're going to see more of it. That's one simple example of it. The other area where you're going to already see AI and really kick in is really industry floor automation. So you're really seeing capabilities or accuracy elements or productivity elements that were impossible previously with traditional rule-based compute. And so as our supply chains are getting robust, and given the challenges we've had in labor shortages, you're seeing a huge deployment of robotics infrastructure and also in capabilities in industry floor automation. These are two examples of things already in production scale and well behind us from an AI capability. Some of the new areas where you're going to see is if I were to pick a horizontal that's just going to pervade all markets, conversational AI is really going to be huge. So where you could talk to machines like you talk to a human being. Machines reason along with you like we do with human beings. No longer is it, hey Siri, hey Alexa. No longer is it, hey Mercedes, wake up. You're just going to be context aware, memory aware, and everything that you do in the cloud is going to be locally embedded on the device, the car. You're driving in your car and you're no 5G access. You do not want to be handicapped. And so you're going to see a huge paradigm in edge-based appliance, and power matters a lot. Most cars are going to be EV-based, and running 1 kilowatt just for compute and AI is not tenable. You're going to see this in robotics in a very big way. Power is at the very core of it. Power efficiency. And I'll leave you with the last vignette, which I think I'm sure everybody's going through this, is data centers are already 4.5-5% of the global power consumption. And we are poised in 2030 or 2032 to double that. 10% of the world is going to be just on data centers in a very, very few years. But contrast, the physical AI world is 28% of the global power consumption today already, pre-AI. If that pivots on AI and has no control on power, I don't know what we're does here. Sure. So getting ahead on power at the edge is really, really critical.
Yeah. And so so tell me a little bit more about where you play in terms of that space. So you are offering software and hardware. And so talk a little bit about your kind of philosophy. So not meant to be a sales pitch about your company, just to kind of talk about conceptually where you are and how you address these problems, and then how organizations kind of engage with you. Who are your
So I've been a student of the physical world for all my career, and so this is an area where I spent a lot of time, and in hindsight built good businesses and technology behind it. My observation is that I think there are two things needed for physical AI to scale meaningfully. Two things. One is performance per watt, not just performance alone. Everybody wants amazing performance, but performance per watt is really, really critical, because you're either limited by power or you're limited by the ability to dissipate heat, which is thermal. So that's table stakes. Number two, this is a world that's diffused. You don't have 5 customers. You have 40, 50,000 customers globally. they need to be self-managed, and they need to be able to derive the benefit of AI without the learning curve of AI. So scalability and ease of use in software is the second vector that's really very critical. People need to be self-managed, and you need to make AI very digestible. The analogy I draw is before iPhone, we used to have thick manuals that came with every one of our phones. You had to press 5 buttons to get a function going. We lived with our Blackberries. We lived with our Nokia phones. Comes iPhone, no manual. You press a button, you move on. That paradigm shift needs to happen to really hit scale in production physical AI, right? So no doubts, those are our two key vectors of capability, and we have done a really good job at both of them. And to your point, I'll not make this a marketing pitch for our company, but I am entirely convinced that those are the two critical things to solve if you want to hit scale in physical AI. And companies that do a good job with it, I'm entirely sure are going to be household names in a few years.
Right. So, what do you see as let me ask you a question. A lot of times, NVIDIA shows up as kind of the default choice for, AI hardware. Where does that work well, and where do you need to look at edge AI players?
Yeah, so I'm amazed at what NVIDIA has done in the last 10 years. I don't know if anybody in the planet is not. Amazing company, and if you will, they've kind of led the charge on AI and AI adoption globally. But our thesis is that I think they're really fundamentally built around a GPU-centric architecture that was built for graphics. And they've extended that capability, and it's fit well in the construct of data centers and in the cloud. They're a general purpose architecture, but you're going to see more and more targeted silicon and software architectures that are divergent for the needs of different markets. I don't believe there's a one size fits all where a GPU-centric architecture can scale for all problems globally. In an early nascent proof of concept, early production, no doubts, I think that's going to be the case. But you're going to see very divergent architectures to solve different problems, particularly as it comes to the physical AI world. Like I told you, power and thermal matter a lot. Software scalability, I don't think you could really be a CUDA company and scale meaningful. You would need to be open source. You need very different architectures, either by silicon or by software, to be meaningfully scaling. This is where I think you're going to see that a one size fits all is not going to work. And our approach is open source. Our approach is solve for power and power efficiency from day one. And we are a radically different architecture than GPUs. Right? So that's really, if you will, as AI scales, you're going to see a lot of divergent architectures really come into play.
Say more about your architecture and how it's different. Maybe you can dive in a little bit of some of the detail.
At the highest order bit, we had the benefit of a clean slate, and we said, if we were to land from Mars, what would we build? So that's a huge luxury that some of the large public companies do not have. Right? So I can do exactly what I want to look at. Number two, ours is a very software-centric architecture. We knew that AI is going to move at a rapid pace from a software evolution, but silicon cadence is once every 3 years. So how do you really deliver something that's market relevant while silicon has a very different cadence than AI? We decided to really take a very software-centric architecture innovation, and our approach has been very different. Third, 70% of the power and the performance gains are more on data management and memory management, and almost less to do with AI. So we have taken full advantage of that architecturally and built something that's very lightweight on-chip cost and on-chip memory. But we have relied on an architecture that uses external DDR, so people can load as complicated a model that they want, but we have clever software architectures that work with it, so that we meet the customer's needs in cost, power, and performance, while really giving them scalability on software. Right? So these are the things that we have done that's very different. And our architecture is divergent and quite different than anybody else's.
And what about the compatibility with existing software and approaches and methodologies that people are familiar with?
So while our architecture is divergent, we are completely open source compliant. So what I mean by that is we can work with any ML framework, whether on Onyx or on PyTorch or TensorFlow. We take them as they are. We're also on Linux. We're also on OpenCL, OpenCV. So these are well-known practices of 10, 15, 30 years. And so everything we do is open source. And I've joked, we are the Ellis Island of ML. So give us your poor, give us your tired, give us your hungry. But once they come in there, America, so that's the closest analogy I draw in that what we do inside is pretty complicated and quite different. But our interfaces are all industry standard. Friction point in migrating from a known base to us is low.
And what kind of companies are actively investigating your architecture? So these are smaller, innovative, entrepreneurial companies, or you also have some of the bigger players. Who's looking at your approach and your methodology?
We have both camps, absolutely both camps. And I would say in the 7 years we run the company, we have gone from early adoption in the market to fast movers. So we are in that phase right now. Any of the big company, I mean, now it's becoming more and more clear that they have AI and that have nots on AI. There's a market separation in even their commercial success. So we are seeing everybody jump in. And we have a good happy medium of both. Early fast movers that are nimble and small, but also large companies that are also becoming nimble and really moving forward. So we have both.
And then what is your competition like? In other words, you said there's a lot of these players, and there's larger organizations and then niche players. Tell us a little bit about that.
Yeah, so I would say we primarily end up competing mostly with our GPU friends. We also occasionally see DSP-centric competition, primarily from our friends in San Diego, and we compete with them well as well, particularly as it comes to automotive and automotive infotainment. There is a lot of smart, amazing startups that have come around, and most of them are ML accelerators only. They don't solve the system on a chip approach that I think we take. And so that's given us a large differentiation against them. And the Achilles heel for the industry is definitely software. And that's an area where we have really done well. So if I were to summarize, I would really say our primary competition ends up being our GPU friends. Primary competition. But we are respectful of everybody's capability. It behooves us to be paranoid and not take anything for granted. We are a startup and we have to fight like hell, anything, everything.
How many folks are you?
So we are 200 plus.
Okay. Yeah.
Our daily struggle is a David versus Goliath story.
So when you look ahead, where do you see the biggest opportunities in physical AI? And where does the hype, particularly around humanoid robots, get ahead of reality? I mean, it's hard to calibrate because things change so quickly. But what do you see as sort of the near term and the midterm future?
Yeah. So I would say, I joke this in a different form. We tend to be totally wrong on expectations on things near term. And we tend to be totally wrong on expectations on the long run. Yeah, so that's just how things...
You overestimate what you can do short term and you underestimate what you can do long term.
More eloquently put than I did. Yes, correct. Yeah. And so I would say...
Overestimate what you can do in a day, underestimate what you can do in a year. Right? Yeah.
So steady state, I would say the volume drivers for physical AI are no doubt going to be automotive, robotics, and drones. Those would be the three volume drivers if I were to pick. And I'm using robotics as a broad category.
Yeah.
As you know, there's so many subsegments even within robotics. But you're going to see this everywhere in medical. You're going to see this in ag tech. You're going to see it in transportation. You're going to see it in aerospace and defense. You're going to see it in smart vision systems. Physical AI is going to scale everywhere. But if I were to pick three applications, drones, automotive, and robotics. So that's where they are. And we're seeing the same three vectors today. And I would say that I think as and when these systems get more and more AI enabled, you're going to see a lot more growth in the vector. As it comes to humanoid robots, my view, and I think maybe I'm a little contrarian in where things are at, or maybe I'm not, is in some ways, humanoid robots is a more complex problem than autonomous cars. There is tremendous hype on humanoid robots right now, and we are participants in it too. So I should not be really poo-pooing that too much. We're enjoying the benefit of that too. But the true production capacity for general purpose humanoid robots in that form factor, where the safety considerations, the scalability considerations, the cost considerations, the power considerations are all factored in. It will absolutely happen, but in my view, at a much longer timeline than we're thinking through today.
What do you see as a timeline?
I would say 10, 15 years.
Yeah.
And so I'm definitely a contrarian in that. And particularly for somebody that's living in the middle of it, I think I hurt my colleagues and friends a little more with my protracted timeline. But I would say cost alone, right? I mean, so, and it all comes down to what's the cost the market's willing to bear? If you want things at $10,000 to $15,000 for a humanoid general purpose robot, somebody to be in your home, fold your laundry, do your dishes for you, and be a sentry, whatever you want it to be, or an AI companion or AI guardian, if you will. When the compute cost itself is $3,500 to $7,000,
Yeah.
it's hard for me to do the math, right? So my rule of thumb is if your system cost is X, your compute cost needs to be 1/10 of that. Be meaningfully viable.
Interesting.
And the systems that are being deployed today are 150 to 300 watts. It's not tenable in a real humanoid form factor, right? So we disagree with many of the peers that are rushing into it. Pilots are fine.
You're saying the compute, it requires that level of power?
Absolutely, right? And
What
so
does it need
compute
to get
alone,
down? What does it need to get down to?
less than 50 watts.
Oh.
And so proof of concepts, and I mean, I think there's a rush into, I'll get my functionality and worry about cost and power later. But this is like saying, let me get a Ferrari and I'll figure out how to make it a Fiat. Some things are not that practical. And so you almost need a very different outlook in saying, if my cost structure is 15,000, how do I back solve for it, meeting my functionality with the cost and power of compute that I need? So I worry many are rushing into it saying, hey, I'll figure out the cost equation later. This is not a cloud where you could just throw things there and worry about things later, right? So you need to give it a lot of upfront thinking. I would submit to you that at this point, China, if you were at CES, has done a far better job in pragmatically saying, if my cost structure is X, $10,000, $15,000, how do I get the most compute, most power efficient, and how do I bridge the gap? Clearly, they're not there today, but they're iterating around a basis that's a far better one than the one that I think I see around, particularly Western Hemisphere. Right. So our thesis is we are built for cost and power as a company. And so no doubts I'm biased in my outlook, but I've never seen systems that want to be $15,000 built on a cost structure of compute alone at $3,500 to $4,000. The economics just are not there. And the cost of humanoid robots are not just compute alone. Now I look at the actuators, I look at the overall mechanical components that we have.
Sure.
And I would say the median of where the humanoid industry is on cost is 70 to 80,000 today. Everybody wants to be 10 to 20,000.
Yeah.
But how we get their story dithers. And this is where I think time is going to be a large consideration. And we've been waiting for autonomous cars for 15 years.
Yeah, of course.
And even mundane, simple tasks like what we're taking for granted on grasping and manipulation at your robotic arm at a human-like capacity is a very complicated problem. It's complicated, if not more complicated than autonomous cars.
Sure.
I joke around this with everybody that's done this for 15, 20 years. For folks getting into it new, there is a huge exuberance. And for folks that have done it for a lot, there's a lot of reticence in jumping into it. Somewhere there's a happy medium, and it's going to happen between those two pole opposite views. So it's going to happen, but at a much longer timeline. I submit to you a totally different compute basis than what people are doing as GPU-centric outlooks today.
Tell me what your roadmap is. So what do you see your organization in the next 3 to 5 years?
Sure. Yeah. So I think by now our tech is well through. No doubts we have an evolution and a roadmap for improving our tech on software and hardware. So that's definitely a case. A lot happening on robotics and automotive, and we really want to double down on that. If I were to pick a macro element of where we are as a company, scaling. I mean, that's really our priority and focus. Scaling on our customers, on our commercial success, scaling on our partner ecosystem, scaling on our go-to-market, scaling on our software teams and our support teams. So if I were to pick one broad theme of what I wake up to every day saying, my God, we need to do better, we need to do more, scaling.
Well, that's great. Well, what an interesting area and full of change and innovation and fast-moving IP. And it really is kind of a fascinating, as you say, it's an interesting time to be involved and alive in this environment and seeing what AI is doing to our world. So this has been a great conversation. Thank you for sharing your insights and what it takes to build these systems and what we're in for in terms of real world settings. And to our listeners, listeners, thank you guys for joining us for another episode of the Earley AI Podcast. So stay with us. We're going to continue to explore how AI is moving from experimentation to impact throughout the society and organizations. And again, thank you, Krishna. I really appreciate your time today.
Thank you so much, Seth. Thoroughly enjoyed the conversation.
Excellent. Well, we'll let you go, and we'll see everyone next time on the next Earley AI Podcast. Bye now.
Bye.
Thank you for joining us on another deep dive into AI innovation. Tune in next time when we introduce another industry expert and discuss how to maximize AI in your world. The Earley AI Podcast is sponsored by Earley Information Science and Vector. To learn more, visit earley.com. That's EARLEY.com. Thank you for tuning in.